Finally, let's talk about a free expansion. In a free expansion, the entire system is isolated and insulated, so no heat goes in. Q equals 0. In that sense, it is adiabatic. But in our previous adiabatic expansion, we were expanding against a piston. And while the pressure changed, we always had a well-defined pressure inside our cylinder. And we were always doing work. So this internal energy had some place to go. In a free expansion, there is nothing to do work against. We open this stopcock, and this comes out totally freely. That means the work is also equal to 0. But if the heat and work are both 0, then the change in internal energy, at least for an ideal gas, must be 0. That comment about for an ideal gas is because real gases often have interactions among them, which may not have a change in the total internal energy, but can result in a change in temperature. For an ideal gas, this 0 change in internal energy means that there will be no change in the temperature either. So, it expands outward, and we have the final, same final, nRT, which means that even though we have a larger volume at the end and a lower pressure, this equals PV. Since the left-hand side didn't change, P1V1 has to equal P2V2. The product of pressure and volume at the beginning equals the product of pressure and volume at the end. You might think that this means it's an isothermal expansion. But remember, in a controlled isothermal expansion, we always had a well-defined pressure and volume. The change in internal energy was 0, but we did work and we absorbed heat. The difference now is that in this free expansion, we don't have a well-defined pressure or volume from the moment we open this stopcock until everything has equilibrated. So, whereas for an isothermal expansion, I could draw a pressure versus volume and draw a nice curve starting at an initial pressure and volume and ending at a final pressure and volume, having a nice curve the whole way. In a free expansion, I don't have this well-defined line here in the middle. There is no pressure or volume in between, so there's no work done. This is still the initial state, this is still the final state, but in between I can't describe it with my PV diagram.